Hello and welcome to a brand new series on ZigWheels called The Workshop. What is The Workshop? Well, in this series, we'll be inviting leaders from the industry to give a masterclass on anything and everything related to the automotive industry. And in the inaugural episode, we are going to be talking about electric vehicles. And who better to have than Mr. Anand Kulkarni, who's the Chief Product Officer at Tata Passenger Electric Mobility Limited. So let's go talk to him. Anand, welcome to
Hi.
the workshop.
Good
Thank you so
morning.
much for your time. And so today's conversation is going to be casual. I'm sorry I might ask you very simple questions.
Not a problem at all.
Yeah, but we want to know all about electric vehicles. And I know you love drawing as well, explaining things. So I've got this as
Lovely.
well, and we have a board as well. So whenever you want, please
Okay.
feel free. So my first question is, what are the challenges and advantages of converting an ICE platform to an EV platform? Because there's a misconception that people just say it's easy. Remove the engine, put batteries and motors, and you're done. Is it that easy?
It has its advantages and it has its limitations. But let's look at it like this. In an area or in an era where you are trying to introduce a new category and you do not know exactly what would be the reception of that particular technology or how it would go,
Right.
it's a very good way to make sure that the customer gets what he is expecting out of an electric vehicle. And it allows us to bring that technology to him faster, in a more optimized way, and without having any compromises on what would be an ultimate solution as well.
Right.
So, if you look at it, no matter which way, it is a more optimized and more appropriate, is how I would say, way to bring technology to see how it works. It is
Right.
like the seeding of a new technology.
Right.
And therefore, there will always be some benefits that you get. These are the benefits that I spoke about.
Right.
But some of the challenges that you have to then overcome are typically in the areas of, because the car originally wasn't designed to be an EV. And what do you mean by designing for an EV?
Right.
That should also be the question.
Right.
One of the things is, how do you do weight management, weight distribution? Because in any car, any automobile, the weight management, weight distribution is fundamental.
Right.
Because that's what manages the dynamics on the car as well. Secondly, the geometric integration of the car is also, or was not done in order to make a EV.
Yeah.
There are ways and means to optimize it, because on an EV today, you have the advantage of having more orthogonal batteries.
Right.
And we will speak about what orthogonal batteries mean. It's always better to do it that way, because it allows you the ability to bring in more energy, it allows you to make more standardized modules, and it allows you to really get form factor agnostic.
Right.
So you don't take away these advantages bespoke. You have to build around this. Those are the challenges. So weight distribution is one. The choices on selection of a key aggregate like a battery is also, in some ways, you have to make specific choices. And then the third choice is, how I would say, is if you look at bespoke EVs, you could probably optimize the seating comfort and the space a little differently than what you would do with a conversion platform.
Right.
But having said that, the benefits of being able to seed the technology, the benefits of being able to bring that technology and allow people to experience it at a very, very accessible point, both in terms of price, technology, perception, customer experience, is just brilliant. And therefore, conversion projects have a certain place.
Right.
It has definitely big advantages. And then, as you can see, migrations often take place, evolution of technology takes place,
Right.
and that's how we keep going ahead.
And of course, you must have learned right from the first Nexon EV to the current Nexon that we have, right? The changes and the integration and the packaging also,
Yes.
right? So how has that changed over time?
You're taking me back to 2018 sometime, which is when we started to lay down the foundations for the Nexon EV.
Yeah.
But at that time also, if you see, we had some experience out of the Tigor EV that we had done for ESL. and one does not always start off on a new technology on a live program. There was always some work that had been done, and earlier I have spoken about the cabled program, for example.
Yes.
That
was back in 2000.
That was 2008.
Yes.
2007, 2008,
yes.
right? And the cabled program was Coventry and Birmingham, light emission demonstrator program.
Right.
So there was a lot of data, information, even in those early days that resided within the company. All of that was implicit information and knowledge that was available.
Yeah.
So we used all of this to sort of get onto doing the Nexon EV. Now, the first Nexon EV was a pure conversion program.
Yeah.
But then as we moved along, changes started coming in because two things happened. One is there was feedback, not only from the customers, but also from the market. Market as in, how does the car behave under certain specific conditions? What kind of temperatures does it run? See, India did not have a high voltage electric product until that time. Nobody knew what a water cooled system would behave like, and the batteries were water cooled. And what kind of temperatures would they run in places like Jaisalmer, places like the western parts of Rajasthan, etc. So all of that information started coming, which obviously as engineers we try and optimize, improve, do better. So you saw that the next avatar of Nexon EV, which was the Max, became much better, different, because not only were we able to adopt a larger sized battery, the 30 kilowatt hour battery became a 40 kilowatt hour battery.
Right.
But then we started moving on what eventually became the active platform. So the work had already started at that point of time. And then along with that, when the Nexon 3 came in, which was last year in September, we added more advantages, optimizations, efficiency improvements to lift up the entire product and the category significantly.
Right. So now we have spoken about cars that have been converted from ICE to EV, right? Now let's talk about Avinya, which is going to be a grounds up EV platform, right? So what are the advantages and how much work goes into actually deciding on a platform and right from the concept stage?
Look at it this way. In the automotive industry, making of a new platform is a massive amount of work. Why is it massive? Because you're not looking at only one product. You're looking at the platform to be yielding you multiple products in the future.
That's right.
Therefore, in a way, the planning function has to be absolutely right. Because if something is going to come a few years down the line, what would be the expectations of that product also needs to be known, or at least evaluated and determined today. And therefore, the platform has to be flexible. It has to be capable of being able to do that. So that kind of work doesn't change irrespective of whether it is an EV or whether it is a ICE. I think the same amount of rigor, the same amount of analysis, the same amount of detail has to go in. In some ways, you could say that today, because EVs are an up and coming branch or technology, you would need to spend a little bit more. Because there are uncertainties. There are certain uncertainties. That's one part of it. But then the second part of it is how do you then geometrically integrate that? And in the geometric integration of a bespoke electric platform, there are advantages in terms of freedom of space. Because when you have an electric vehicle, you are having a very, very compact powertrain. Compaction in terms of the power and torque that it delivers. For a similar kind of a ICE engine, it would be much larger.
That's true.
So that's one part of it. Secondly, the EVs tend to need lesser space in the front, which is what we call as overhang, in order to meet the crash performance. Therefore, they liberate a fair amount of space between the two wheels, and which we want to make as wide and as long as possible, so that you can spread the battery around at the bottom, and that not only gives you the weight and the weight distribution on the car that we spoke about earlier, but it also means it gives you more space inside, because it creates a flat floor, and therefore internally you can have a space of one segment up vehicle. Now when you do all this, you have to then meet other regulatory expectations. be that of crash performances,
Yeah.
be that of NVH, be that of visibility requirements or ground clearance requirements and similar sort of things.
Right.
So when you try and solve these problems, in certain ways, you would find that the EVs do become much better, much easier. Of course, you need to, as I said, the planning process has to be extremely intense because you're looking at something that is going to go down even 10 years down the line. And that's how the entire process works.
Yeah. So clearly the progression and the way EV as a platform or EV as a car has progressed over say 6 years now, right? It's been
I mean, electric vehicles have been there.
have been there for a while, but in India, in the Indian
In
space.
India, you could say that a high voltage electric vehicle which needed to be thought about in all these terms. The Nexon EV was the front runner, and it's been around for now. The entire work has been about 6 years. Yes.
Correct. So in 6 years, there have been massive changes, massive progression as well. How do you see the next 10 years? Is the progression going to be as steep or is it going to level out a little bit?
So certainly the progression is going to be there and phenomenally there. And I'll tell you two or three areas where we're going to really have massive changes happening. One thing is, as more people get used to electric vehicles, they realize the fundamental shift and the benefits that electric vehicles bring in. I mean, let's look at it this way from a customer-centric perspective. You drive an EV, because of the very low level of vibrations and very low level of noise that you are subjected to, driving long distances becomes so much of less fatigue. You could walk out of the car feeling almost fresh. As
I can second that.
I mean, I do drive a lot, and it's really amazing how an electric vehicle shapes up that way. So that's one part. But look at it from other perspective. What's changing in the industry today? A lot of connected cars are coming in. A lot of autonomous driving is coming in. And a lot of software integration is taking place. We've spoken a lot, and we've discussed. The industry is discussing a lot on software-defined vehicles, SDVs. So this is one part of it. The second part is that battery technology, electronics technology, is improving at a extremely rapid pace.
Right.
All of these benefits can be brought on into the cars, making them not only more geometrically compact while giving good space internally, but it would also pull down the overall investment and the cost of making these components as the scale builds up. So all put together, you have technologies which are shrinking in size, but expanding in capability. You have the software layer built on top of it, which can unlock hitherto unrealized or unvisualized capabilities. And you have all of these things happening while giving great comfort, great convenience, great NVH expectation to the customer. So it's dramatic. I sometimes say that we are at the cusp of a second revolution in automobiles. The kind of changes that have happened in the last 6 and what are likely to happen in the next 5, 7, 10 years is just amazing. It is going to transform the industry.
Got it. That's amazing. So now that we've got a brief introduction about EVs, so what are the factors you take into consideration while making an EV? Like, for example, what factors go behind deciding battery capacity, for example?
So since you have spoken about the battery capacity, let me first talk about that. Battery capacity is an important criteria and an important parameter to get hold of properly.
Correct.
And first and foremost, it begins with, so it's a balance. First and foremost, it begins with what kind of a vehicle are you trying to create? Or what is the use case of that vehicle? Because if it were to be a highway vehicle, then you certainly need the battery capacity to be of a certain range, certain capacity, certain usable kilometers, rather than not. But if it were to be a city-driven vehicle, then there's no need to put in that much amount of capacity because it would just make the car overweight and more expensive. Batteries still happen to be one of the most important cost factor in an electric vehicle. So that's one part of it. The second part of it is you have to select which chemistry are you going to go with.
That's right.
Because for a hot market like India, you would want safety to be paramount.
Yeah.
And therefore, there are certain types of form factors of batteries as well as chemistries which lend themselves suitable to that.
Right.
The third thing is what kind of a cooling system would you employ? So batteries can be cooled by air cooling, or they can also be cooled by water cooling.
Okay.
Performance wise, if you have a high performance vehicle, it is always better to go with a liquid cooling system. If it is a low performance kind of a car, then air cooling works just as fine, and if the loads are not very high. Now, once you have done that, it is important to how do you mount the batteries underneath, and that's very, very tricky because since the batteries are below the floor, your vehicle needs to have adequate ground clearance to be able to match all of the road conditions. Otherwise, you would end up scraping the battery from the bottom, and that's not a good thing to happen.
Absolutely not, especially
absolutely
considering the cost.
Not only that, but because it's a electrochemical entity, you don't want to put in forces or loads into the battery which can change anything and lead to undesirable effects on the battery. Once you have done that, you also need to then look at the mass that you have put in, because more capacity means more mass. The moment you have more mass, you need to contend with what happens in the event of a crash. While you can always retain the occupant inside the vehicle safe, or you can ensure safety for him, it's also important to maintain the safety for the battery as well.
That's right.
And at the same time, it's important to maintain the safety of the passers-by.
That's true.
Because if vehicles are going to get heavier on account of EVs, then you need to make the structure so that in case of an impact, the other person doesn't suffer serious injuries. At the same time, the structure is stiff enough to not allow the forces to reach the passengers. So all of this is a very, very complex thing. I mean, I tell you,
it is absolutely, because hearing this as well, because generally whenever people talk about electric vehicles, they think that it is easy just to stack batteries and you're done. It's not.
No, it is certainly not. So I would tell you that a large part of the development effort gets spent in optimizing this precise thing, because you tend to improve the stiffness in one place and it has a detrimental effect in some other place. You tend to soften up one place and it has a detrimental effect elsewhere. So you need to make sure that the
just finding the balance.
It is absolutely the balance. And this balance can only be found out through a series of trial and error simulations. So I can tell you, we go through hundreds and hundreds of simulations before we strike the right balance.
Okay. So now that we are talking about batteries, you spoke about chemistry as well. Do you think chemistry is going to change a lot going forward, or is it going to be the same? Just the technology is going to be such that batteries are going to get more denser and better at packaging as well?
So this is a very interesting aspect, and I think it's a very important question that you ask. So if you look at what's happened to batteries over the last decade or so, one is the chemistries have been by and large stable. Of course, there is always an attempt that cell makers are trying to improve the efficiency and the energy content and the rating of the batteries. So 2 or 3 areas are very, very important, and I'll talk with what are we trying to do, what is the industry trying to do on existing batteries, and then we will talk about the technology part of how it's changing. So on existing batteries, we essentially have 3 cell formats. We have a cylindrical, we have a prismatic, and we have a pouch.
That's right.
I mean, our phones have pouch cells, and the cylindrical format is what we used in torches or what we use in our good old mouse or things of that sort.
Pencil cell.
Pencil cells. And then we have prismatic batteries, which are essentially rectanguloid sections. The attempt today is to try and increase the energy efficiency of those batteries, which mean that by changing the chemical formulations, you're trying to see how in the same size, same format, same space, you can pack in more energy, and the batteries can therefore become more denser. There is also a lot of work that is currently going on in packaging of the batteries.
Right.
So people talk about doing cell to pack, or people talk about doing cell to chassis.
Chassis, yeah.
And that's essentially how do you try and fit in more cells in the same
That's right.
envelope of the vehicle that you have.
That's right.
The second part that is also happening is how do you charge those same batteries faster? Meaning, if you could charge the same battery faster, then you do not, hypothetically, you do not need that capacity, because
That's true.
you could always stop at a charger,
Yeah.
and you could get those
Fast charge.
batteries charged faster. So charge is often determined by a parameter called the C rating. Meaning, if you could charge a battery from 0% to 100% in 1 hour, it is called 1C.
Yeah.
So people are trying to go to 2C, 3C, and there are experimental batteries which are available even at 6C.
Okay.
However, that will need infrastructure investment, and that's a whole set of other aspects that we look at. So that's one part of how things are moving. On the new technology side, people have been speaking about sodium batteries, which is instead of lithium, you use sodium batteries, which is a more abundant and less toxic, chemical in that sense. We've also been, the industry has been talking for a long time about solid state batteries. And solid state batteries essentially give you the advantage of not only a slightly higher degree of material, but more safety, because even in case of ruptures, punctures, or penetrations, the batteries are absolutely safe. And then people are also talking about today metal batteries, metal air batteries. For example, lithium air batteries, or zinc air batteries, aluminum air batteries. Those kind of batteries are also being spoken about. But I think lithium ion batteries have reached a stage of maturation today where the process, the size, the energy content, and the ability to manage it on a car is significantly mature. And therefore, this will tend to be the main force for some time, at least in the future.
Okay, got it. That's amazing. Okay, so how do you determine what's the max charging speed? Like, how can higher speeds be unlocked as well?
The charging ability of a cell depends on, is governed by, or determined by, or controlled by the current, charging current that it can take. So if you can charge at a higher current, it will charge faster. Simple as that. Now, why can't it charge faster? Because the chemistry either does not allow it to happen. I mean, there's just this chemical limitation, or the cell would become unstable. It would take in too much of heat, and which you don't want. Then it would lead to a quick deterioration in the cell life overall, durability of the cell, and that's certainly not what you would want to have. Therefore, the slower that you charge, the better it is, but the faster that you charge, the more usable or more use cases tend to open up.
That's true.
So that is one determinant, and that is what I said earlier. If today there is 1C, people are talking about, or actually there are cells which can go to 2C, 2.5C also, and people are talking about experimental cells at 6C also. So that will open up. But the other point is you need to have a DC charger which can pump in that much amount of current. You look at it this way. If we have a 40 kilowatt charger for or 40 kilowatt hour battery for Nexon, at 1C it's going to pull in 40 kilowatt. At 2C it is going to pull in 80 kilowatt. At 3C it is going to pull in 120 kilowatt.
Correct.
Therefore, you need to have infrastructure of that nature. And tomorrow, when we have larger and larger battery capacities, let's say we go to a battery capacity which is 80 kilowatt hour, we double that capacity, let's say, on a larger vehicle, it improves. If you do 3C on that, you're going to need a 240 kilowatt charger. Now at 240 kilowatt charger, you are going to draw an immense amount of currents.
That's true.
And that has to be done in a very reliable and a consistent manner. How many places will you be able to do that? So in most places, if it's not going to be usable, then what is the upgradation that has to happen within the infrastructure also needs to be looked at.
So basically, it is more about moving more like with the times as well. The
So
charging.
it is definitely
Yeah,
two areas that have to move up in tandem.
in tandem.
It is to happen together.
Infrastructure and
Yeah, it's not enough.
Yeah.
I mean, at vehicle level, you could certainly do certain things.
Yeah.
There's no doubt about it.
Yeah,
Because technology is available, you could do it.
that's true.
But if you're not able to harness that,
Harness that. What's the
then
point?
what's the point?
Yeah, your cost just goes up.
Yes.
Right. So now talking about fast charging, there are a lot of questions that come in. Is it okay to fast charge your car all the time, or should you slow charge it sometimes?
Typically, what happens is, and this is a question that many people ask.
Yeah,
and,
yeah.
So thank you for that,
Yeah.
and it's an opportunity to clarify one more time. So typically, what happens is, even if you fast charge, you are essentially fast charging it only in a certain portion of the battery capacity.
That's
So
true.
let's say the battery is depleted fully, and once the battery has depleted fully, you start charging it.
Yeah.
Up to a certain point, it will charge at a fast rate,
Fast rate.
and then the algorithm and the BMS and everything else sort of tones down
Yeah.
the charging
Slows
rate.
it down,
It
yeah.
slows it down. Why does it slow down? Because if you charge batteries rapidly, then there are chances of cell imbalances taking place.
That's true.
And you do not want these cell imbalances for the simple reason that the BMS is constantly monitoring what's happening on the cells. And the moment it realizes that a certain cell has hit its maximum value, as a precautionary method, it will cut the charging off.
Yeah, yeah.
Similarly, when a cell drops down in value in terms of the voltage, and there is one cell which hits the rock bottom, even then the BMS says no more discharging or no more running, and we will drop it down. So you need all these cells to move together.
That's true.
It's like, let's say you had 25 cisterns of water, and you were trying to fill it with one hose. You needed the water to rise in all the cisterns together,
That's true.
rather than it increasing in one and not increasing the other.
Correct.
So they are all supposed to be
Correct.
very connected.
Correct.
And that's what you have to do. So the charging rate actually manages that. Now, it's therefore possible to do fast charging always.
Correct.
So long as you allow for the 100% to be hit. Because by allowing for the 100%, you are essentially allowing the slow charging also to happen beyond 90%.
That's
or
true.
beyond 85%.
That's true.
And that allows the balance to be restored.
Okay.
But if you say, oh, I'm very smart about it, I'm going to charge the battery only 80% because that's where it charges the fastest, then you're not allowing the battery to regain the balance.
Got it.
And therefore, you could have, after 10, 15, 20 charges, the battery is desperately trying to hold on, trying to balance itself.
yeah.
But there could be some anomalies which creep in, and therefore it's not such a good thing. So, by all means, charge full charge. Allow it to go to full charge, because then it just makes life simpler.
Got it. Got it. That's amazing. That even I didn't know actually. Okay, my next question is again related to batteries. Why are they expensive?
That's an interesting one. So,
Because a lot of people say, ki, why are batteries so expensive? And they always have this fear that whatever warranty period your battery has, then after that I have to replace the battery. Is it true as well?
so let me, I mean, there are too many questions.
Yeah, I know.
We could go on for half an hour.
Yeah.
But, so why are batteries expensive? I think one of the first important things that we have to realize is that the raw materials in these batteries, which is the lithium salts, there is a lot of copper that goes into it. They are in some ways commodities which are expensive, and therefore that's one part of it. Of course, being commodities, they are subjected to variations, and sometimes they become higher, sometimes they become lower. In fact, there was a tremendous surge and spike in the post-COVID era, and now things may have returned back to more or less a stable
How
situation.
do you price a car in that case?
So that's something that we are not going to talk today. But that's one part of the input. The second is, and it is really interesting for our viewers to see what a battery plant looks like, or a cell plant looks like. It is a very, very intense, completely automated chemical plant with absolutely no room. It's like a clean room. It's like a surgical clean room. and that
Eat from the floor type.
yes, absolutely. So you could get into a plant, and the amount of contaminants in the air would be in terms of particles per square cubic meter would be a very low number. So it is absolutely surgically clean. This all requires a huge amount of investment. There's a lot of power processing, power for processing that has to go in. All of these factors, they are expensive. The third part is that you can use one particular cell for a particular application. There is no universal cell.
Okay.
There is, so for example, and that is why these form factors have come out, the cylindricals, the prismatics, the pouches.
Yeah, that's right.
And therefore it is to each one, whatever
application,
suits.
whatever is
Now,
required.
each of these investments are also massive, because development of a new cell, and look at it this way, it's a very, very intense energy carrying part.
That's true.
So it has to undergo significant amount of testing, validation, to make sure that it does not behave in a manner that is even remotely unintended.
Right.
And therefore people have to do it very, very carefully, very and there's a lot of development work that has to go into any new cell.
Right.
After that, it gets mounted into a car, and the car is supposed to run not for a year, 2 years, 4 years, but it is supposed to run at least for 10, 12, 15 years.
Yeah,
We would probably want to own it a little longer also.
Especially in India, yeah.
Especially in India, yes. So therefore, there is this entire thing that has to happen. There's a lot of engineering development work that happens. So therefore, it is still a little bit more expensive.
Okay.
But then coming to your second question, do you need to replace them during a lifetime? We would think no. We would think no, for the simple reason that today we offer 8 years or 1,60,000 kilometers as the warranty. Now, there are two ways in which a cell can show degradation, and one of course is in terms of its number of charges, number of charge discharge cycles. And that is certainly above the 1,60,000 kilometers. So you look at a Nexon Max, for example, a 40 kilowatt hour battery, it typically gives you around 290, 300 kilometers of range. And if you look at it, it is going to far exceed the 1,60,000 kilometers that you need to have, because that 1,60,000 kilometers will be achieved in 500 cycles. Whereas the batteries typically are anywhere upwards of 1,700, 1,800 cycles. So there's no problem with that.
Got it.
So, but there is life. There is something that has to go on beyond it. There are rare occasions where the battery might have to be replaced, but not so much because it has gone down in life as much as it is because there is an anomaly which needs to be fixed. But otherwise, for example, if you look at the Leaf, the Nissan Leaf, the first generation batteries, 2010, they're running well even now. There is a small degradation in the range that has happened over a period of time, but the batteries are still running well.
That's true for ICE vehicles as well.
That's true for ICE vehicles as well. I mean, you look at an ICE engine, it gives you 20 kilometers to a liter today. Over a period of time, wear and tear, the clearances and tolerances open up, etc. It starts consuming more oil, it starts consuming more fuel, and then the average drops down. Same things happen.
Got it. Got it.
The behavior is similar.
Got it. And the cost of battery, what you spoke about, like, because there's so much development and so they have to be careful about so many things. With scale, will the price come down?
With scale, the price does come down, but more importantly, because advancements in battery technology are continuous.
That's right.
So people are learning to extract more energy out of the same amount of raw materials. People are learning to package more energy within the same footprint or within the same space. So all of this help. A useful indicator would be where were the battery prices in 2010.
That's right.
And they were probably at $1,000 a kilowatt hour. Today we are significantly lower. And just to give you an example, Ame, you know, when power banks came in, power banks were typically very, very expensive. Even a 3,000 milliampere hour power bank was something that I could show, look, I've got a power bank. Today, 15,000, 20,000 milliampere hours power banks are available for
$1,500.
Fraction of a cost.
1,200, yeah, that's true, actually. That's true. Now coming back to the battery and the degradation, right? So one of the questions is what considerations are made regarding the environmental impact and life cycle analysis of EVs compared to conventional vehicles? For example, disposing of batteries or reusing them. So what are the considerations made while making an EV as well?
The reuse of the batteries or refurbishment of the batteries is a very important part, and that's something that we all have to consider. Now, when we say that batteries have lost their usage, it is not lost their usage and we have to discard them.
Got it.
So, for example, a fresh battery or a fresh cell starts at 100% capacity.
Yeah.
Over a period of time, it drops down, keeps dropping down. We say for automotive usage, when it goes down below, I mean, this is something that different OEMs do.
Yeah.
When it goes down below 80% or below 75%, then you don't want to use it any longer for automotive purposes. And therefore, when you asked me earlier, will I have to replace the battery? The answer is, if you are a person who does not mind a small degradation in the range, you could continue running the battery.
Yeah,
There's no
that's
problem
true.
with it.
That's true.
And that's you.
And safe too.
It is safe. That's typically not going to happen within the 15 years. So let's not worry about that.
Right.
But having said that, let's say it does drop to 75% or 70%, whatever that number may be, determined by each OEM. You could take off these batteries and put them to reuse. You could, for example, use them to power some smaller installations.
Got it.
As an example, we've done some trial work with batteries that are needed to be the auxiliary batteries for telephone towers or mobile network towers. Could be done. You could pull out these cells and use it in inverters, which will power home appliances.
Got it.
You could use it for storing energy from solar or wind and use it whenever required. So this is what you could
Wherever
do.
electricity is an issue,
Correct.
it can be used there as well.
So this is the second use of the batteries. Beyond this, once, I mean, there is a certain life to that, and beyond this, that will also deplete.
Yeah.
You can then pull out all the raw materials, process them, and use them for second use in the batteries, or making fresh batteries. Because after all, you're trying to, you don't want to waste the expensive
So you
as
can
well
repurpose
as
them.
yes, expensive as well as valuable mining materials that you have brought out of the mines, and you can certainly repurpose them. So all the materials, including the copper, the electrolyte, the aluminum cans, or the lithium salts, all of them can be repurposed.
Got it. But cost-wise, right now, is it feasible? At what degree is it happening right now? Because obviously, electric cars as a concept is still very new. But eventually, maybe 10 years down the line or 15 years down the line, how equipped are we?
In terms of equipment, in terms of capability, I think the answers are found.
Okay.
There's nothing to say that, oh, do we have answers? The answers are found. In terms of scale, your question is absolutely right. The electrification in India started with the Nexon EV in that sense, right? And it's been only 4 years. So, and these batteries are going to last for at least another 5-6 years and perhaps a little longer. So, that question, today we don't have that amount of established supply chain for the repurposing. But as we go on, certainly this will be established. And it's not only for vehicles. I mean, we should not look at this problem only from a vehicular perspective. India has also mobile phones and other devices where the batteries don't last as long.
That's true.
And therefore, that supply chain and this thing will start, but it will start gradually.
So maybe some simple questions, right? So how, now that you don't have a ICE engine in an EV, right? Obviously. So how does a heater work in an EV? Because there's no source of heat.
I understand. So you can actually do heating in two ways. One is you could actually make a very integrated thermal management system where you want to conserve the heat from the batteries also. See, batteries are exothermic in nature. So when they discharge, they give out heat. which is the reason why we want to cool them down.
True.
So you could capture that
Okay.
heat and you could use it into the, it could transfer to a liquid, and that liquid could be used to augment the capacity in the cabin for comfort.
Right.
But then you will also have an issue, or you could have an issue where the capacity may not be adequate. For that, you can always have a electrical heater.
Right.
Now, the electrical heater could also be a water-based heater, or it could be a air-based heater.
Yeah.
And that's what we do in all our cars,
Okay.
in order to make sure that the cabin comfort is assured at all points of time. So we have an electrical air heater that gives you the right level of comfort within the car at even low temperatures.
Got it. Now, coming to a very important question. Tata Motors has always focused a lot on safety.
Yes.
Right? Always, like, you all set benchmarks. So, is it like, for example, a Nexon ICE and a Nexon EV, are the load paths the same in a crash test?
So, can
you actually, if possible, please?
Well, let's try and do that. Let us try and do that. So, for example, so you have a force F coming here. You would want to, so these are the three lines of direction of how the forces will be taken up. It's important for you to see if most of the force could be passed down, because then it goes into
this
the
is in an EV.
This is in an EV.
Yeah.
And then some part of it is also taken up by the A pillar, but specific, and this is what happens in a regular car as well.
Yeah.
This is what would happen.
Yeah.
In an EV, you are also trying to see if you can take some part of the load in the lateral direction.
Okay.
So that you can manage the structure much better, because what is happening is you are looking at more masses, you're looking at a heavier weight, and you're looking to absorb energy, so that it can be, it does not pass on to the occupants.
Got it.
Now, if you make the structure too stiff, you will make it very, very stiff. Then it will impart a deceleration jerk to occupants. And because you are restrained by the seat belt, it could lead to forces on the chest. That's not great. So you need to have the structure yield to a certain extent, right? And when you have the structure yield to that extent, you have to make it softer, but not soft enough that it pushes everything inside, and then the sheet metal is impacting the driver's body.
That's right.
And because that's another way of injury taking place. So this optimum way has to be managed, and in a lot of times we want to pass on the impulse below the floor. But as I said, some part going into the A pillar and some into the...
Why below the floor? Because that's where the strength lies with an EV?
One is strength, and the second one is, therefore, if the force passes down, you are preventing injuries to happen to the driver.
Got it. And how much more complicated is this to do as compared to...
So essentially, as I said, you need to make sure the balance between decelerations and deformations is optimized. And that is really the crux of it. So you use different materials, different sections to be able to manage that. So this crash pulse, management of this crash pulse is what takes up a large part of the activity.
So then, development-wise or parts-wise, difference between, say, a Nexon ICE and Nexon EV, a lot of parts will be different, right?
Yes, they are different. They are different. So, for example, if you look at the Max, the floor is different.
Got it.
The floor is completely different, and then the floor attachment points and the points for the mass to be managed well, or the impulse to be momentum to be managed well, are also different. So you could either choose it in terms of the geometry of the parts, the sections of the parts, or you could also look at it from a strength of the raw material which goes into making those panels.
Okay. So that's like almost developing a brand new vehicle.
It is. It is.
Except for the top hat, obviously.
Look, there are obviously pieces of the base architecture which are available. Knowledge is available, and what areas would become vulnerable in case of a higher mass are known. So you know what areas you're going to reinforce, but you don't know how. And you don't know whether it's as I said, it's just not about strengthening it to the best possible extent, because then you could get into a deceleration related issue, and chest impact, etc., etc.
Right.
So that's what you
Right.
have to look at.
Okay, great. And also you have to factor in that the EVs are more heavy as well, right?
Correct.
In this.
Correct. Correct.
So now talking about EVs are more heavy. Now
Mhm.
coming to suspension a
Mhm.
little bit. So if you can just give me a brief overview of how do you make those changes when it comes to say because the car is heavier.
Mhm.
Is there any other way that you use to tune suspensions because the car is heavier, so that it while driving you don't really feel the weight, right? Because that's exactly what we all try to achieve as well.
So in any suspension, it is the stiffness of the springs.
Again, are the load this thing are different?
No, no.
Okay.
So the loads are essentially the same. You need to make sure that so
We can have a sit. Actually,
I can show you.
Huh.
So you actually have a damper which let's say you have a damper in there as well.
Yeah.
Essentially you have to so there is a force front and a force rear.
Got it.
You have to manage the frequencies. Fundamentally, you have to manage the frequencies of both these axles.
Axles. Yeah.
So you know what the mass is. You have to manage the stiffness of these springs. Once you get the stiffness of these springs right in order to make sure that the frequencies are matched, then you have to work with the damping.
Right.
To ensure that those frequencies, the vibrations or the movements on account of those springs can be properly absorbed by the shock absorbers.
Right.
If you're able to hit that balance, then even if the mass of the car is higher, you will still find that the car is actually doing what it wants to do.
No, because I remember driving the Nexon EV first when it came out.
Yeah.
And today, if I drive it, there's a huge difference, right, in the way it drives as well. Because obviously, just like how battery technology and motor technology has rapidly progressed,
Yeah.
similarly, I think understanding of what you can tune and how you can tune has
One
that
thing
changed?
is understanding.
Yeah.
But the second thing is that you have the mass here in the center.
That's right.
And the distribution of weight across these axles is also an important determinant.
Got it.
In a front wheel driven car, let's say the Nexon that you are talking about in terms of ICE, it was a front wheel driven car. In the front wheel driven car, 55%, 58% of the total mass of the car is centered on the front wheels.
Got it.
The balance 43%, 45% is centered on the rear wheels. When we did the Nexon EV, it became 50-50. Now 50-50 is such a great balance. That's what engineers would always want to strive for. Because then you have exactly uniform loads
That's true.
across and you have very uniform behavior
That's
that
true.
you can really, really be very happy about. And
Yeah.
that's what you actually see in the cars.
That's true. That's true. Okay, and talking about now a little bit about battery management and efficiency management, right? So, in terms of regen, for example, how do you determine that these are the steps that we need, right? High regen, low regen. What is brake regeneration, energy regeneration? Why is it better for it to be selectable? Why isn't max regen always good?
Every car, when it is in motion, it possesses a certain amount of energy, and as it slows down, you use brakes in order to slow it down.
Yeah.
So when you use brakes to slow it down, that momentum is essentially transformed into heat
Yeah.
at the brake disc and brake pad level, and that's dissipated away. It's wasted.
Wasted energy. Yeah.
Electrical vehicles offer this as a great opportunity to recover that because the motor can regenerate.
That's true.
So when the motor is driving the wheels, that time it is a motor, but when the wheels, when you decelerate, the wheels are driving the motor, and that is at that time the motor is.
So the motor acts like a generator.
It's like a generator.
Yeah.
And what does it do? Because it has a great reservoir in the form of the battery, it starts pumping in that generated energy into the battery, recharging the battery.
Yeah. Yeah.
This is a fantastic opportunity here for EVs, which is not available in ICE cars.
That's true.
Now, what happens is, how much energy can you recover? A lot. The answer is a lot.
Okay.
On electric vehicles, depending upon what kind of drive cycle, what kind of use pattern that you have, you could almost regenerate up to 20% of the total energy.
Wow.
Which is really a
great.
lot.
Yeah.
Yeah. Now, there can be a specific boundary to how much you can regenerate. Because see, it's like this: if you regenerate more, you're going to decelerate more.
That's true.
So if you try and recover more energy, you're going to stop. And that's not going to feel good, because it's just going to feel like start, stop, start, stop, start kind of a thing. So you need it to be good in a manner of keeping with the flow of traffic. And it's not easily determined.
And India is not the easiest place to do it as well, right? Because of the traffic and
Absolutely. So you can have different traffic. I mean, given our cities, in Mumbai, crowded traffic may be different than Bangalore,
That's true.
than Pune.
That's true.
So you need to have this user flexibility that can be given to adjust himself to what the traffic condition is.
That's true.
And therefore you have to give, or if you give a selectable regeneration, then the user will be able to adjust it to his or her use pattern and maximize out of that.
Got it.
That's the simple thing out of it.
Got it. Got it. So basically you can determine, for example, now you spoke about 20% can be recovered, right? There are new technologies that are people talking about, like brake by wire, for example. So that more of it, basically the electronics can decide how much regeneration can happen and how much brake force is actually required. So are these technologies far away still, or
No. In fact, the Nexon Max onwards, we've got something called as the IV back,
right?
Which is the intelligent vacuum assisted booster, which is precisely this. So
Okay.
it blends.
Okay.
It blends the requirements of the user as well as what is the most optimal thing, and maximizes the amount of regeneration into the car.
Got it.
And this IV back is a feature that is, or a device that is currently being fitted only on the Tata cars.
Right.
There's nobody else who does that in India yet.
Got it.
Certainly not in the class of vehicles that we are talking about.
Got it. Got it. Okay. Now let's go back to range a little bit. So there's a theory that 0.01 reduction in drag equals to 8 kilometers of gain. Is it true?
Aerodynamics plays an important role. It does not sort of behave differently with an ICE
Absolutely.
or differently with an EV. It's a regular feature, and anything that moves will have resistance.
Yeah.
And so be it locomotives for that matter, they will always have some resistance. And as you go at a higher and higher speed, you will find that the resistance becomes higher and higher.
That's true.
Which is why streamlining of the bodies, streamlining of the shapes is so very important. Now, aerodynamics has a very peculiar characteristic. Above 60 kmph, it becomes a very, very important determinant. But below 60 kmph, you could probably live with it. I mean, it still makes a difference, but you could live with it. That kind of stuff. So, in cars, if cars are going to operate at 80, 90, 100 kilometers, sometimes up to 120 kilometers as well, it certainly becomes an important determinant.
Right.
And we want to conserve as much energy as possible so that it can be translated into range.
Right.
Therefore, what you do is to try and streamline the body to the best possible extent.
Got it.
Now, streamlining the body to the best possible extent, if you do it in a theoretical fashion, you could have cars which will not be able to ply on the Indian roads, or ply on any roads for that matter. Because I don't know if you've seen these Australian solar challenges and things of that sort, but they have this extremely teardrop shaped cars which can extend right up to 4, 5, 6 meters, 7 meters, and
long tails,
essentially to not have layer separation as the air passes through. But that's not feasible. You have to stay with cars that are manageable on crowded cities and
regulations, safety,
parking, so many things. So what you do is you try and minimize. Now, when you try and minimize, if you have a clean slate, it's always the best thing to do. But very often you don't have a clean slate. You have to optimize from what you already may have. And that improvement is where we try and do it with aero aids, rather than necessarily redefining the entire shape of the car. Now, what are these aero aids? For example, if you make pathways where air can slip through, then it's always good.
Yeah.
So you open up apertures within the bumper, for example,
True.
into the wheel arches, or things of that
So
sort.
disturbed air can escape from
Correct.
there as well.
Or you try and put in a layer underneath the vehicle so that the air slips past rather than goes into some complicated shapes and crevices and adds resistance. You try and add elements like spoilers, for example, so that the separation of the layer happens a little downstream and it does not create too many eddies.
Right.
So all of these factors are looked at. And you are right when you said 0.01 because that is a 10 count improvement in aerodynamics.
Sounds very less, but it's a
Sounds
lot.
very, very less, but it is a very important parameter. And whether or not it realizes into a 8-kilometer range benefit is a different thing, because it certainly depends on the area of the car also, because the
And
total
what speeds you're driving at
and
as
what
well.
speeds you're driving, what is the original thing of the original range of the car, depends on a whole lot of things. But yes, I would say engineers fight for even 0.01 count improvement, and that's certainly that we look forward to, and there's a lot of optimization that takes place here also.
Right. So one more question that people generally ask: flooding. So how do you, like, what happens if I drive an EV through floods, right? What part needs extra protection, or what are the changes that you have to make as a manufacturer so that cars are safe in flooding situations as well?
So to a normal customer, the vulnerabilities that might be going in the back of the mind is, first of all, battery. What will happen if my battery gets soaked? Because we are all used to saying that, batteries, if they fall into water, they are all going to either short, or they're going to malfunction, or something else is going to happen. So this is one vulnerability. The second is, because we've all been spoken about ICE vehicles should not go in water, because the moment you ingest water, then you can have a hydrostatic lock, or you can have some kind of a problem there. And the third is, what happens to my wiring harnesses. So I would say each of these three cases, let me address the battery first. So the battery is IP67 sealed. What does IP67 sealing mean? It is basically an ingress protection from dust and moisture. Now, it does not mean that never ever and at no depth, or at whatever depth, will water not enter. It just means that even if your car were to be submerged in a 1 meter height of water, 1 meter is 3 feet. So 3 feet above the battery is already at 1.5, 2 feet. So up to 5 feet, if the car is sitting submerged there for more than half an hour, the batteries will not have ingress of water.
Got it.
So there will be no problem with that. The motor itself does not have induction of air or anything. That is also sealed. The key parts are already sealed, so there is going to be no ingestion of water there. And lastly, for the electrical wiring harnesses and the connections, the key connectors are absolutely well sealed again to IP67, and therefore you would not have any ingress of water. Now this is all good in theory, and cars behave, they are subjected to heat, moisture, dust, rain, everything over a long period of time. So what happens if something happens will be the question also in the back of the mind. So there are safety strategies. So the moment that, let's say, something fails there, it reports to the car as an isolation loss.
Got it.
And that once that isolation loss is reported, the battery immediately shuts itself down to prevent any further damage, or to, more importantly, this entire thing about whether it will then pass current into that water, because water is a conductor. All of those fears get cancelled out because the battery just disconnects itself.
Got it.
So it would rather sit in that kind of a situation, not having traction, but it will certainly not pass on any current or anything else into the water. So from that perspective, it is absolutely safe.
Right.
In fact, I would say that the water wading capabilities of an electric vehicle are far greater than the water wading capabilities of an ICE vehicle for exactly this reason.
Now we were talking about safety, about batteries and everything. So a lot of these fast charging places, they ask you not to sit in the car while fast charging. Is it true? Is it safe to sit inside the car while the car is being fast charged?
It is absolutely safe to sit inside the car. because that's the entire thing, you know.
Yeah.
In fact, you could actually sit inside the car, run your AC and be comfortable, or you could probably use the arcade.ev to watch a film.
Good plug, good plug. So it is safe, you're saying,
Yes.
right? Okay. So now coming to one more very simple question. How does the smaller battery, the auxiliary battery, the main battery get charged? Because there's no alternator. It's not the same functioning as say
Yeah.
nice.
So you are absolutely right. And we have what is a DC to DC converter,
Okay.
which it acts like a step-down transformer, taking the energy from the high-voltage battery and pumping in that amount of energy into the 12-volt battery,
Got it.
so that the 12-volt battery constantly stays energized, because a lot of the vehicular systems are still on 12 volts.
That's true.
So whether you look at headlamps, tail lamps,
yeah.
wipers, window winders, the AC fan, the front engine cooling or the motor cooling fan, all of these still run on the 12 volts. So the auxiliary battery is also a key element, and the DC to DC converter does that job.
So if you accidentally leave the car headlamp on or the cabin light on, so like in a normal ICE vehicle, it just dies and turns, like obviously it loses charge, but will the same happen to a EV as well?
So there are algorithms which are built in, and the DC to DC charger charges when the car is on the move.
On the move.
Okay, so you shouldn't.
So it'll behave
It
in
will
a
behave
similar
like
manner.
an alternator. It will behave like an alternator.
Got it, got it. So you have to be careful about that
Yes.
with an EV as well. Got it. So now coming to the industry as a whole. So how do global and regional regulations influence the development and deployment of electric vehicles?
Can you sort of make that more specific? What are you asking for?
So basically, government regulations.
Yes.
So how do you, because it's a constant change over there as well while you're developing vehicles. So how do you decide, and while developing a product, you have to take into consideration everything, right?
So I might not be able to answer you from
Got it.
a international market perspective, but I can certainly try and attempt it from a India market.
Yeah. Yeah,
So,
this is from an Indian market
correct,
perspective.
correct. So, for example, the government bodies and the regulatory bodies have a very important role to play in terms of shaping the sector.
Got it.
And if you look at FAME schemes,
Yeah.
the faster adoption for manufacturing of electric vehicles, that was the impetus in the right direction.
Yeah.
Because that set down the criteria for what vehicles India could have,
True.
and it actually defined an accessible point for electric vehicles, which was very, very important. And then, if you made vehicles to that specification, you could sort of get incentives
True.
or get subsidies.
True.
And those were extremely important in the initial phase.
Yeah.
They continue to be important, in fact.
Yeah.
That has then been followed up by, for example, what is the productivity linked incentive, the PLI.
Yeah.
And in PLI, essentially, you need to achieve a certain level of domestic value addition, which means that a certain part of the vehicle has to be, value addition to the vehicle has to be done within the country. And that's
Got
a
it.
50% threshold. Now, what happens when you have these kind of regulations is it encourages the industry to start doing those solutions, because then there is an incentive.
Got it.
There is a reward for being able to do that. And that has brought in more localization, that will always bring in more localization. And therefore, you start looking at making some of those parts, most of those parts internally. Of course, at Tata Motors, we set up the entire battery manufacturing, the EDU manufacturing, entire thing here. We invested a lot in terms of localization right from the first vehicle. And all of this is shaping up to not only help the industry create capability and competence, but also become more competitive and create this entire ecosystem.
Got it. Got it. Now, obviously, EV is a very interesting place. A lot of developments are happening, right? So there are a lot of people who are actually aspiring to work in this industry as well, right? So for young engineers interested in pursuing a career in electric vehicle technology, what advice would you give them?
I think It's a difficult one. This is the most difficult one that you've asked me of the entire day.
No, but I think it is the most important one because
I
a lot
think
of
so.
people watching this would want to know, like,
No,
what
I
exactly
think
skill
that's right.
set would they require to actually fulfill
Yeah.
this job?
An EV, therefore, I would say, is no different than any other automobile. It's a technology, yes, and there are specific bits and pieces of knowledge within that technological domain which will be unique and which people will learn. What is heartening to see is, Ameya, that today, whether it is the Baha competitions, the SAE competitions, a lot of this is focused on electric vehicles. So
true.
students coming into the industry
true.
are already aware of technologies, already aware of what is happening, and that's such a good thing. From, I go back 30 years when we were passing out of college, and these kind of competitions weren't there, and therefore all our knowledge was more bookish in that sense. But today I think the generation is already better. When it comes to specific cases, there are areas where which do not get necessarily treated in colleges in a very explicit way. But those are areas where the industry can certainly step in. We do a lot of courses with institutes. We help upskilling, we help training, and we help a lot of institutes create curriculum to be able to do that. But I think what students need to bring in is the ability to learn, is a willingness to learn, rather than come from a perspective of saying, oh, I've done this in my college and I know how this works, because it's evolving so fast. It's just not possible to say, I've learned everything and I therefore have to just apply it. So if people come with that bend of mind, then I think it's not difficult at all. Areas which are going to be very crucial, very important in the future is software-defined vehicles. There's a lot of work. India does not have adequate number of people today. So software-defined vehicles, software integration, application development on electronics and in cars, thermal management, energy efficiency. These are all very core areas that crucial ones, absolutely.
Now, a great example of what you spoke just now about learning is you, because you also started off very different and you entered a space of EVs, which is, again, I would say similar but very different as well. So how difficult was it for you, or interesting was it for you to actually take this up?
Look, I knew the process of making cars. So for me, it was an incremental addition in terms of understanding the battery, understanding the power electronics. I cannot claim to be an expert in power electronics. I'm not. But I certainly know the entire part of how to bring a vehicle together and how to make teams work together. I think that's what matters at my position and at my role, because I have a great set of engineers and team members who understand more details. So I just have to ask the right questions.
Got it. So the last question, and maybe a funny one. So what are the most absurd rumors you have heard about EVs?
Oh wow, there are so many myths. There are so
the
many
funniest
myths.
one, maybe you can think about.
Let me think. But myths like, for example, it takes forever to charge an EV. Not true. You asked me a question, can my EV wade through water? It will stall? Not true.
Or give you electric shock?
It will give you an electric shock? Not true. Not at all. Will my EV suddenly stop, and will it misbehave and things of that sort? No, certainly not true. Will my EV work in the altitude of Leh Ladakh and
or in
Jaisalmer temperatures? Absolutely, it will work. It is more comfortable. So all of these are myths that I think the solutions that we have given in the last few years have helped to dispel, but we have to keep doing more. We have to reach out to more people, and that's what we do with series like this.
Okay, that's amazing. So thank you so much, and that's it for the first episode of.
No, I have to tell you, it's been a pleasure talking to you as usual.
Pleasure is all ours.
And it's been so nice and free flowing. And thank you for asking those questions, because very often you assume things,
Yeah,
But-
because I was a little afraid about asking certain questions because they were so simple and silly.
but,
but they are questions that people are asking.
No,
as
there's
well.
no question is a silly question.
Yeah.
So long as it leads to helping people dispel some doubts
Absolutely.
or clarify some thoughts.
Absolutely.
It's been a pleasure.
Absolutely. Same. Thank
Thank
you
you
so
so
much. Thank you so much.